Hello. If you already saw the precedent videos, you are familiar with sign convention, rules, and references used in this calculation sheet. If not, see the videos related to shear and bending moment for explanation. In this video we will learn about stresses in beams and safety factors. Always, in Mechanical Engineer Partnership website shows the page, I section in calculators, normal and shear stresses for beams in bending. Figure shows the repartition of normal and shear stresses in section AA of an I-beam in bending. Analyzing the graphic, we observe that the normal stresses, tensile or compression, are maximums in the extreme fibers and zero in value, on neutral fiber. The shear stress is maximum in the neutral fiber and zero in extremities. The neutral axis goes trough the centroid of the shape. See the video about area moment of inertia with more explanations about centroid point. On the graphic of shear, we observe that the shear stress have two values for sections situated at y1 distance respectively y2 distance. Generally the stress due to the combined bending and direct shear stresses is maximum on top or bottom of the shape, but in certain situations can be maximum in sections at y1 and y2 distances. Let's have an example. Initial data in International System Unit in left side have equivalent data in Imperial System Unit in the right, but the two blocks work independently. In Imperial units, dimension bottom flange B1, 4 inches. Dimension top flange B2, 5 inches. Dimension height H, 6 inches. Thickness web T, 0.25 inches. Thickness bottom flange T1, 0.375 inches. Thickness top flange T2, 0.375 inches. 4. Shear force in section AA of beam and bending moment in section AA of beam. If you have already the values, write it in correspondent cellules. If not, choose calculators and then shear, moment, and deflection of beams. Choose the right option for your case. For example, simple supports, center load. If consider already the initial date in the data table, and look at the results in the blue table. In this particular case the shear force and bending force are maximus in the middle of the beam. If RA section is the middle of the beam, copy these values, and return, calculators, normal and shear stresses of beams. I section, paste the values in the correspondent cellules, 112.4045 pound force, 56,202.25, pound force inches, replace the values for dimension bottom flange B1, 4 inches. Dimension top flange B2, 5 inches. Dimension height H, 6 inches. Thickness web T, 0.25 inches. Thickness bottom flange T1, 0.375 inches. Thickness top flange T2, 0.375 inches. ASTM standards, minimum yield strength of the beam material SY32 Capesifor and 1018 steel in hot rolled condition. Calculate. The results are in blue table. The first block of results is geometrical properties of the section, area, position of centroid, area moment of inertia, section modulus, radius of gyration. The second block in related to the calculation of stresses tensile or compression, in lower or top fiber, shear stresses in neutral axis, combined or principal shear at y1 and y2 distances. The third block is in respect with design factors in longitudinal sections with maximum absolute values of stresses. Chose the minimum value for design calculations. Design factors came to be expressed in terms of a stress and a relevant strength, and expressions such as strength divided by stress. For values smaller than 1 will occur failure. For quality, use these calculator sheets for verification complementary, with other calculators, or methods like finite element, and to find these geometrical properties. Thank you. And see the other videos with explanations about beams deflection, area moment of inertia and the calculation of stress.